The next example in quadratic functions that I would like to review is when you have vertex form. And remember that vertex form is when you have your function. Remember, f of x means that you have a function that replaced y in the form a times x minus h squared plus k. And that a is that leading coefficient we were discussing earlier. Now, our vertex of hk. There are a couple of different ways to think about this. One way to think about finding h is that we always take the opposite of what's inside the parentheses. Some students like to take what's inside the parenthesis, set it equal to 0, and we subtract 3 from both sides to get the x by itself, which means that we have x equal to negative 3. And remember, x is our h for our vertex. H is our x coordinate of the vertex. We would have negative 3, comma, and k is whatever is at the end, whatever we add or subtract. Here's positive 8, so we're going to have 8. If it was negative 32 at the end, minus 32, our k value would be negative 32. Axis of symmetry is always in the form x equal to h. It is a vertical line, which is why it's x equal to, and it's whatever our h coordinate of our vertex was. So we get x equal to negative 3. We have a quadratic. We know we have a quadratic because of the square being the highest power. Okay, so we have a quadratic function, which means our domain is always negative infinity to positive infinity, all real numbers. The graph opening up or down all depends upon a, our leading coefficient. So a in this case is negative 2, which we just said is negative. And if it is negative, we open down. And the reason for that, we're opening down like a frown. When you're negative, you're frowning. The corners of your mouth go down. With our vertex, we just said that our graph opens down. We know that our vertex is our turning point, which in this case is right up there. And because it is up there, our vertex is a maximum. It's the highest part. Okay. Some of you may not be comfortable with this next piece yet, so make sure you pay close attention. We need to find the range in interval notation. With my parabolas, I draw the graph a lot. So let's draw that graph one more time. This time I'm going to make it a little bit bigger. Okay. We know our vertex is negative 3, 8. Okay. And we know that it is a maximum. Remember that our range is all about our y values. Since our y values are all we care about, let's get rid of the x values. I'm only going to concentrate on the y values. So if I'm looking at my y value and I'm thinking about my graph, we said that this was our maximum. This is our highest, which means that our graph plummets down into the negative infinities. But remember, we always do smallest to largest. So if we start at the bottom, we would have negative infinity always with a parenthesis because we never reach either of the infinities. And then we reach the top, the peak, the maximum of 8, which means we have 8 with a bracket. And we use the bracket again because we actually hit the y value of 8. Okay, let's talk about this increasing, decreasing thing again. And I am going to continue to use my little graph here. We have 3, 8 for our vertex, negative 3, 8, my apologies. And remember, here with our intervals, we only care about the x values. Since we only care about the x values, ignore the y values. It's still looking at my little diagram on the right-hand side. Okay, so we have our x equal to negative 3, which is our axis of symmetry. We have negative infinity on the left, positive infinity on the right. Remember, we read from left to right. So if we start with our graph on the left and we follow it like we're driving a car, we're going up and up and up and up and up, which means that we are increasing. So we're increasing here. And then we have our turning point and it plummets down. And when it's going down, that means it's decreasing. And because I did these little numbers, I know that I am increasing from negative infinity to negative 3. So I can answer part H. And then I know I am decreasing from negative 3 to infinity. I know it's not the prettiest, but it's a way to go about it without reinventing the wheel each time. Okay, you don't have to have the perfect graph. You just need to be able to sketch it, and you can get to these answers. All right, next piece. We're supposed to find our x-intercepts. To find our x-intercepts, we need to plug in y equal to 0, or another way to look at that is set your equation equal to 0. So we are going to take our negative 2 times x plus 3 squared plus 8 and set it equal to 0. I'm going to scroll up for a second. I am taking our entire equation and getting rid of the f of x and setting it equal to 0. Because we have a quantity squared in here and no variables outside of the square, we can use the square root property. Square root property says that we need to get the quantity squared by itself before we do the actual square root property. So our first step, we're going to subtract 8 from both sides. We have negative 2 times x plus 3 quantity squared equals negative 8. We can't take the square root of both sides yet because that negative 2 is in the way. Since we have negative 2 times our parentheses, we're going to divide both sides. We have x plus 3 quantity squared is equal to positive 4 because negative 8 divided by negative 2 is positive 4. Because we have the square by itself, we can take the square root property, which means that we are going to take the square root of both sides of the equation, remembering your plus or minus on the right-hand side. On the left-hand side, the square root and the square cancel each other out. And on the right-hand side, when you're evaluating your radicals, first thing you do is put it into your calculator. You hope for a nice whole number. If you get a nice whole number, no more radical. If you get a decimal, that means that you need to do the fractor tree and simplify it out. Square root of 4 is 2. We got lucky. Not done yet because we don't have x by itself. And you subtract 3 from both sides. And we get x is equal to -3 plus or minus 2. Do not make the mistake of saying that this is plus or minus 5. Instead, you need to break this up into its two separate answers. We have x is equal to -3 plus 2, and x is equal to -3 minus 2. So x is equal to -1, and x is equal to -5. Because it wanted to have ordered pairs, remember ordered pairs of x-intercepts are in the form x, comma, 0, or if you want to be a little bit more general, some number, comma, 0. Our first ordered pair will be -1, comma, 0, and the second one is -5, comma, 0. Almost done with this problem. I put a lot in this one to help review. Y-intercept. To find the x-intercept, we plugged 0 in for y. To find the y-intercept, plug in x equal to 0. So we're trying to find f of 0, which is -2 times 0 plus 3 squared plus 8. You can put this all in at once in your calculator, or if you want to do the steps, you can. 0 plus 3 is 3. 3 squared is 9. So -2 times 9 plus 8. -18 plus 8 gets us -10. This is y equal to -10 for our y-intercept. But as an ordered pair, remember y-intercepts are in the form 0, comma, some number. Ours, because we plugged in 0 for x, it's going to be 0, comma, -10. And don't forget to put your parentheses, otherwise you do not have an ordered pair.